Subscribers, welcome back to another episode of Science with Surback. Today what we're going to be talking about is section 15.2, which deals with solution concentration. Now before we get going into these notes, there are a few objectives I would like you to be able to accomplish by the end of this video. So objective number 1, state the concentrations of solutions in different ways. And objective number 2, calculate the concentrations of solutions. So we get underway here with our solutions, and we start out here with this term or this definition of concentration. So concentration is defined as a measure of how much solute is dissolved in a specific amount of solvent or of solution. Now, concentration can be described in two main ways, and they are as follows. Number 1, we can describe a concentration or a solution as dilute. Or number 2, we can describe it as a solution being concentrated. Now, I should have added here, these are two ways we can describe it qualitatively. Now, quantitative concentration is expressed as a ratio of measured amounts of solute in solvent or solution. Now, we have three main ways we express this quantitative concentration. The first way we can describe a quantitative concentration is percent by mass or volume. The second quantitative concentration method we could use is molarity. And the third common concentration or quantitative concentration terminology we use is molality. All right, so what we're going to do here is we're going to use all of these terms we've used to describe concentration, and we're also going to associate that with how we actually calculate it. So we're going to start with our quantitative concentrations, and then we'll move into these qualitative ways we can express concentration. So let's first start out by talking about percent by mass. So percent by mass is going to express a ratio, or going to be expressed as a ratio of a measured amount of solute to a measured amount of solution. Now, usually percent by mass is going to describe a solution in which a solid is dissolved in a liquid, like having solid sodium chloride be dissolved in water. Now, with most quantitative measurements here, we do have a formula that can be used to express percent by mass. Now, the formula for percent by mass is as follows. So the percent by mass is equal to the mass of the solute divided by the mass of the solution. And because we have to have this as a percent, we are going to multiply this by 100. Now, I want to pause and just talk about this mass of the solution. Remember, the solution is composed of a combination of the solute plus the solvent. So I'm going to write this down here as a special note that the solution is equal to the solute plus the solvent. So when we go to solve and find the mass of the solution, we need to add together the solute and the solvent. So let's go ahead, let's try an example where we use the percent by mass formula. Okay, so our problem says here, in order to maintain sodium chloride concentrations similar to ocean water, an aquarium must contain 3.6 grams of NaCl, or sodium chloride, per 100 grams of water. What is the percent by mass of NaCl in the solution? So let's go ahead, let's rewrite that formula that we just put down on the last page. And remember the percent by mass, which I'm just going to use the percent sign here, but the percent by mass is equal to the mass of the solute. So mass of solute divided by mass of solution multiplied by 100. So we start here and we can read the problem, but we're not going to find any percent by mass. So our percent by mass is ultimately going to be the thing that we are looking for, or the variable that we are looking for. Now, the mass of the solute. We have to do a little work here, but the mass of the solute, remember, the solute is the substance that is being dissolved. So the mass of the solute is going to be the mass of NaCl, because in this case, NaCl, or sodium chloride, is being dissolved. Well, we look here in our problem, and it says we have 3.6 grams of NaCl. So in here, we're going to put 3.6 grams of our NaCl, and then we get down to the mass of the solution. Now remember, from the previous page of notes, the mass of the solution is going to be the solute plus the solvent. Well, in this case, it is going to be our NaCl plus our water, which I'm going to use the chemical formula for water, H2O. Now, our NaCl, we just got done saying, is 3.6. So we're going to have 3.6 grams of NaCl plus our amount of water, which in the problem is listed at 100.0 grams. So we have 100.0 grams of H2O. If we turn to our calculators here, we add together 3.6 plus 100.0, and we get a value of 103.6. So our mass of our solution is 103.6. Now we have all the players of the game. We can use that to find the percent by mass. So the percent by mass is equal to our mass of our solute, which is 3.6 grams of NaCl, all divided by the total mass of the solution, which we just got done calculating to be 103.6 grams. We then need to multiply that by 100. So here's how I like to put this into my calculator. I like to put 3.6 divided by 103.6. I press enter. I leave this value in my calculator and I multiply it by 100, because that's what the formula says. And rounding to two total digits, or two significant digits, this becomes a 3.5% by mass of sodium chloride solution. And again, how we label that is 3.5% by mass. And then it's always important to remember, what is that solute? What is that substance that is dissolved in our example or our problem? That is going to play a crucial role as we go down further and further the road with concentration. Okay, so that was one of the percents we talked about. We now need to shift gears and talk about percent by volume. So the percent by volume is expressed as a ratio of the volume of the solute to the volume of the solution. Now, percent by volume is going to describe solutions in which both the solute and solvent are liquids. And because percent by volume is another quantitative measurement, it does have a formula associated with it. So the formula for percent by volume is as follows. The percent by volume is equal to the volume of the solute divided by the volume of the solution. And because it is a percent, remember we need to multiply this by 100, okay? So now we need to have this in mind once again. I'm going to write it down. We had it with percent by mass, but our solution, it's very important to remember, the solution is comprised of the solute and the solvent. So when you find the volume of the solution, you need to add together both the solute and the solvent. Okay, so let's go ahead, let's utilize this information to solve an example problem. All right, so we have our example problem here, and it says, what is the percent by volume of ethanol in a solution that contains 35 milliliters of ethanol dissolved in 115 milliliters of water? So again, I always like to start out by rewriting my formula. I know we just saw it, but our percent by volume, which I am going to use the percent, I am going to use the percent sign here, but the percent by volume is the volume of the solute divided by the volume of the solution. And it needs to be multiplied by 100. So we can read through this problem, but we're not going to find percent by volume. So our percent by volume is going to be our question mark. Now the volume of the solute, remember that is what is being dissolved. The substance in a lower amount is going to be this of ethanol. So our volume of the solute is ethanol, okay? So the volume of the solute is ethanol. And if we read in the problem, our volume of ethanol, it states, is 35 milliliters. So we have 35 milliliters. And then our volume of our solution, I'll write that down, we'll talk about it. Remember, the volume of the solution is the solute plus the solvent, okay? So in this case, it's going to be our ethanol plus our water, because that is our solvent. So right here, we already stated that we had 35 milliliters of our ethanol. So we have 35 milliliters of ethanol plus our 115 milliliters of water. So plus 115 mils of water. And I'm going to abbreviate that as H2O. Now, we turn to our calculators here and we add together 35 plus 115. And we get a volume of 150 milliliters. So our volume of our solution is 150 milliliters. Now, we have all of the values we need. We can turn back to the formula and plug those volumes in. So in this particular problem, we are going to have the percent by volume equal to the volume of our solute, which we just calculated to be 35 milliliters of ethanol. So 35 milliliters of ethanol divided by the total volume of the solution, which if we look closely here, the total volume of the solution is 150 or 150 milliliters. Now, because this is a percent, we need to multiply that value by 100. So here's how I like to do it. I like to take 35 divided by 150. I press enter. Then I multiply by 100. I kept that value in there and just used the answer. And so my answer to 2 significant digits becomes 23% by volume of ethanol. And again, this is going to be really important. Yes, you have that numerical value. You have that numerical value in your particular answer here, but labeling the substance or the solute that is dissolved is very crucial. Okay, so now we can move to that second quantitative term that we talked about in the beginning of notes. So we'll turn to molarity. So molarity is defined as the number of moles of solute dissolved per liter of solution. Now, when we talk about molarity, we refer to molarity as molar concentration. And I should note here that this is one of the most common units used when we're expressing concentration. Now, we need to talk about how we can express molarity. Number one, molarity is going to use a capital M. Number two, we're going to place a numerical value in front of that capital M. Now, let's turn to some examples to show you what I mean when we talk about molarity. So, number one, if we have a 1M solution, we can talk about what that means. So, 1M means that we have 1 mole of solute per liter. Now, a 1M solution would be read as 1 molar. Another example would be a 0.1M solution. In this solution, there would be 0.1 mole of solute per liter. And this solution would be read as 0.1 molar. Now, just like we've seen with our other solution concentrations, we do have a formula for molarity. So the formula is as follows. The molarity, which remember is a capital M, is equal to the moles of the solute per the liters of solution. Okay, so keep this formula in mind as we go and we try an example problem on the next page. Okay, so here it says a 100.5 milliliter IV solution contains 5.10 grams of glucose. What is the molarity of this solution given that the molar mass of glucose is 180.16 grams per mole? So again, the first thing that we need to do is we need to write down our formula. So again, we're dealing with molarity. That is a capital M, and that is equal to moles of solute divided by liters, which I'm going to abbreviate as an L, of solution. And we get to this. We look for a big M, and you will not find a big M. So ultimately, the big M is going to be our question mark. And then we get down to our second variable here, our moles of solute. Well, first off, we have to determine what our solute is. Remember, the solute is the substance being dissolved. So in this case, it's going to be our glucose. Now, we're not given moles, but we are given grams. So I'm going to do two things here. Number one, I'm going to write down the formula here, C6H12O6. And number two, I am going to write down the number of grams of glucose. So we have 5.10 grams of C6H12O6. Now, to convert from grams to moles, we need to use that molar mass, and so we need to set up that conversion. Remember, with our conversions here, what we are going to do is we're going to cancel diagonal units. So we're going to put grams of glucose on bottom, and we are going to put moles of glucose on top. Now, lucky for us, we already have the molar mass of glucose provided. It's the 180.16 number, and that 180 number is associated with grams. So I'm going to put on bottom here 180.16 for every 1 mole. So to find out how many moles of glucose we have, all we need to do is we need to take 5.10 divided by 180.16. We get a value of 0.0283. So I'm going to write this below here. We get a value of 0.0283 moles of C6H12O6. Okay, so now we have moles of solute. We need to find liters of solution. So again, our liters of solution. Liters is not given, but we are given a volume unit, which is 100.5 milliliters. Now, we, from that 100.5 milliliters, can find the amount of liters in our solution. So what we're going to do here, we are going to divide the number of liters by 1,000 to get it into units of liters. Okay? So all we're going to do here is take 100.5 divided by 1,000. We press enter and we get a value of 0.1005. So we get a value of 0.1005 liters of solution. All right, so now we have all of the values that we can utilize this molarity problem. So Rm is equal to the number of moles, which we just took the time to calculate, to be 0.0283 moles of C6H12O6, all divided by 0.1005 liters of solution. So we plug this into our calculator. We take 0.0283 divided by 0.1005, and we press enter. Now, rounding to 3 significant digits, we are going to get 0.283. So this would become 0.283, and it is big M to be read as molarity, and then you need to put that solute. So that solute, or that substance there, is C6H12O6, and that would become our answer. Now, we can go one step further. We can actually go a couple steps further with molarity. Remember, I said it's the most commonly used units for concentration. So we can go a little bit further. We can do a little bit more in depth and in detail. And one of those things is actually preparing solutions. So we'll transition here to the next page of notes, which is preparing solutions. So we have to keep in mind this, that experiments often call for only small quantities of solutions. As a result, we must make these items called stock solutions accordingly. Now, stock solutions, all they are solutions that we are actually going to utilize in lab experiments. And so we have a defined set of steps to prepare stock solutions. So number 1 is to determine the molarity of the solution that needs to be made. And this will typically be given to you. The second thing is to determine the number of liters of solution to be made. This step will typically also be given to you just like in step 1. The third step is to use the values in steps 1 and 2 and find the number of moles of solute needed. Now, to do this step, you need to use the molarity formula. The fourth step is to convert the moles found in step 3 to grams using the molar mass of the solute. And then the fifth and final step is to prepare the solution by adding the number of grams from step 4 with the total liters of the solution desired to correctly produce that solution with that right molarity. All right, so let's utilize these steps to answer the next problem. Okay, so our next problem here says determine the mass of sucrose needed to make 100 milliliters of a 0.1 molar sucrose solution. So the first thing that we should really do is we should write down the formula that we have for molarity. Remember that our big M, or capital M, is equal to our moles of our solute divided by liters of solution. Now, what we need to do, we need to determine what we have and don't have and solve for that unknown. So our big M here is actually given at 0.1 molar sucrose solution. So what I'm going to write down is 0.1 big M, and then we have C12H22O11, the formula for sucrose. Now, our moles, we could search all day long, but our moles of solute is not given. There's no moles or there's no grams like we've seen previously. So our moles of our solute, which remember is C12H22O11 is not given. Okay, so this is going to be our question mark. Now, our liters of solution, again, liters of solution is not explicitly given, but we are given that we have 100 milliliters of this particular solution. So remember, to convert milliliters to liters, we just need to divide that value by 1,000. And we'll turn to our calculators to accomplish this. So we're going to take 100 divided by 1,000, and we are going to get a value of 0.1. So we get 0.1 liters of our solution. And now we can plug these values in and solve for moles of our sucrose. So here we go. We have 0.1 molar, which is equal to the moles of our solute, which we don't know. I'm going to label it as X moles of sucrose. C12H22. Whoop, jumped ahead of myself. C12H22O11. Okay, and that is divided by our liters of solution, which we just got done calculating to be 0.1 liters of solution. Now, what we're going to do here is we're going to pretend that these are equivalent fractions. So I'm going to put 0.1 over 1, and then I am going to cross multiply 0.1 times 0.1. Okay, so I take 0.1 times 0.1, and I get a value of 0.01. Okay, so this is going to be 0.01. If we think about the units, remember, molarity is equal to moles over liter. So that would be mole over liter times liter. The liters would cancel out. You'd be left with moles. And then, hey, 1 times X is just 1. So this would actually be 0.01 moles of our sucrose here. Okay, so we found out the number of moles, but the problem says, hey, what is the mass? Because we don't have scales that measure moles. We have scales that measure in grams. Well, we're going to need to use the molar mass, okay? And so how we do this is, again, we're going to set this up as 0.01 moles of C12H22O11. We're going to cancel out moles of C12H22O11. And on top, we can finally put grams of C12H22O11. Now, we could take the time, use the periodic table, and find the molar mass, or you can just look it up online, and that's what I did here. The molar mass of our sucrose is 342.30 grams per mole. Again, this 342 number is associated with grams, so it goes down here in this gram slot. So we have 342.30 per every 1 mole. And now all we need to do is we need to take 0.01 times 342.30. We press enter. We divide that by 1. And we get a value of 3.4 grams. When we round to 2 digits, 3.4 grams of that sugar, of that sucrose. So this right here, 3.4 grams. Took us a while to get there, but we get 3.4 grams of C12H22O11. So I'm not going to write this down here, but what we would do is we would measure out 3.4 grams of sucrose. We would then add enough solvent, in this case water, to make exactly 100 milliliters or 0.1 liters of solution. So we add this amount of our sucrose, then we put in the water to get us up to 100 milliliters or 0.1 liters, and that's how we would make that 100 milliliters of a 0.1 molar solution. Now, because, once more, the concentration unit, the most common concentration unit, is molarity, we can talk about one more thing, and that is diluting solutions.